Okay, let's do another problem. This time is about rearrangement of carbocation. And the question here says, which of the following alkyl halides, or something like that, right, is most likely to undergo rearrangement in an SN1 reaction? So which of these will undergo rearrangement in SN1 reaction, which is the following, and I'm going to give you structures, right? First, the problem has IUPAC name, so always the first step if you have IUPAC's name is to draw the molecules. So here we have 3-bromopentane, and so we do 1, 2, 3, 4, and 5 bromopentane, 3-bromopentane. Let's do one more. It says here 2-chloro, 3,3-dimethylpentane, dimethylpentane. Oh, geez, this ink is not going. Okay. Dimethyl real pentane. Luckily, I'm going to draw the structure over here, and that is 1, 2, 3, 4, 5, 2-chloro, 3,3-dimethyl. And then it says another one, 3-chloro, pentane. So similar to the one, only that we have a chlorine. Yes, then we have, what is here? Bromocyclohexane. Cyclohexane. And let's do that over here. The cyclohexane with the bromine here. And last one that I have in this question is 1-bromo 4-methyl cyclohexane. Again, question is IUPAC naming. So you start with the parent chain, cyclohexane, and then it says 1-bromo, so I'm just going to put my bromo here, and in 4, it says methyl cyclohexane. Okay, these are my substrates. So the question is saying which of these will undergo rearrangement, meaning you probably have a carbocation that's not as stable, and as it rearranges, it becomes something more stable. So here, let's make the carbocations and think whether or not this might be rearranged. So after loss of leaving group, here you're forming a secondary carbocation. Right. If you did a migration of a hydrogen, so hydride shift from any of these two positions, you're still going to form a secondary carbocation. So this is not likely to rearrange because it's not going to go to anything more stable. Same reasoning here for the 3-chloropentane, because again, after the loss of a leaving group, here you're going to be forming a secondary carbocation. But what you have in the neighboring positions is again two hydrogens on each side. And as we said before, if you migrated one of these, 1 or 2 hydride shift, you will be making another secondary carbocation. So it's not likely to rearrange. For the same reason, we're going to say that 3-chloropentane is not doing that. So I'm going to just draw an X here by the compound. Not likely to rearrange, not likely to rearrange. Let's work on this one. If you form in bromocyclohexane, if you have the loss of leaving group, let's do this. And then you form your carbocation. That's secondary. And any of the positions by the side have hydrogen, yes, but if you did a migration here over to that carbon, you're still going to form another secondary carbocation. Doesn't make sense. It doesn't help. It's not more stable, so it's not going to happen either. So if we do the same analysis to the last substrate, here you have again, you're forming another, so loss of leaving group, and you're forming a secondary carbocation. And you don't have opportunities to migrate alkyl groups or other things to make a tertiary carbocation. We just have hydrogens again, so not a chance. So that's also not going to happen. But I am going to erase that. That substrate is more interesting in that sense. So all of the other form a secondary carbocation. Now, if I do for this compound, this, I have rearranged, and we have determined that that didn't undergo rearrangement. So what's left is the compound that I have there, so 2-chloro-3,3-dimethylpanthane. So let's do the loss of leaving group. If we did that, cry departed, I'm gonna be making the following. That's not a hydrogen, that's a metal. Okay, here we have. And you're making a carbocation. That is secondary. But if we did migrate now, not a hydra, but a methide, so that methyl group with the pair electron is a methide shift. So it is 1, 2, so the next position, right? And now let's see what we are forming after we do the method shift. When we do this, the structure that remains is the following. So now you're gonna have one metal here, the other migrated over this position, and now you have a tertiary carbocation, which is more stable. We came from a secondary to tertiary, so going in that direction, that rearrangement will happen. So the question said, which of these structures, which substrate is more likely to rearrange in an SN1 reaction? So your answer is this compound, because you form a secondary carbocation that then will rearrange to a tertiary carbocation that's more stable.